So, good day to each and everyone. So, we are here guys to present to you the fieldwork exercise number 6 entitled Trigonometric Leveling. Introduction. Double-rotted differential leveling is a method of determining the difference in elevation between points by employing two routes simultaneously. Two turning points are established such that at each setup of the leveling instrument, two sets of independent backsides and foresides are taken. Employing double-rotted differential leveling provide a continuous check on the process of determining ground elevations while the work is in progress. The method is also useful when there is an urgent need to undertake differential leveling in a short period of time where no established benchmarks are available for checking results. Objectives. First is to acquire and develop the skills of determining the vertical distances or the height and elevation of a remote point by applying trigonometric and related analysis. Number 2. To develop the skills of reading vertical angles using theodolite or total station. Instruments and accessories. The first one is theodolite. Next is leveling rod. Next is markers. It's either chalk or marking pins. And next is measuring tape. Next is plumb bob. And last but not the least is range pole. Procedure. Number 1. Set up the theodolite at a convenient location and call it point A where the leveling rod and the remote point are visible. Number 2. Using the telescope, take sight at the topmost remote point. Then, read the vertical angle and record as A on Table 5 trigonometric leveling. Number 3. Take another sight for the second trial. This is done to determine the precision of the observations. Number 4. Calculate the mean of the two vertical angles or the angle of elevation or not the zenith angle of the specified point from the first station.
Set the leveling staff or rod vertically near the base of the remote point and take the leveling foresight. Example, horizontal line or zero vertical angle on the rod to determine the height of the instrument. Transfer the instrument level, which is the theodolite, towards the location of the remote point and designate it as station B. Then measure its distance by taping from its initial position, which is the station A. Record this as distance AB. After centering the bubble of the instrument level, sight at the same topmost remote point, which is decided before, twice using the telescope, and record as B on table 5, labeled as trigonometric leveling. After recording these two observations on vertical angle, calculate the mean. Level the telescope while at B and get the height of the instrument by sighting the same leveling rod near the base of the remote point. Analyze and see figure below. The right triangles formed to determine the height of the remote point. This fieldwork will not consider the effects of the combined correction of Earth's curvature and refraction.
Determine the difference in elevation between two instrument setups. Difference in height instrument is equals to h sub 1 minus h sub 2. Consider the triangle B'EF, then solve for the distance x using the tangent function. Tan beta is equal to h sub 1 minus h sub 2 over x. Determine the sum of the distance AB and distance x for the analysis of the oblique triangle A'FD. A'F is equals to AB plus x. Consider triangle A'FD and use sine law to determine the distance FD. AB plus x over sine multiplied by beta minus alpha is equals to FB over sine alpha. Consider triangle FDG and determine the height of the remote point DG. Sine beta is equals to h minus h sub 1 over FD.